This is lesson 1.6, and we're going to review area and perimeter and a little bit about polygons in this unit. So a polygon is a closed figure where we have the sides that have common endpoints, and each side intersects exactly with two other sides, but only at their endpoints. And those are vertex points or vertices. So, the side of a polygon is a straight line and it's connected at each end. Diagonal is a line segment from one corner to the other, and there is a formula that I just kind of threw in there for you, but we won't really be working a whole lot with diagonals. So at each end point, we kind of already talked about this, each endpoint of the side is a vertex of the polygon. So plural is vertices. So I want you to try and fill in as many of those names that you can. So if it has 3, triangle, and go through and see as many as you know. So click pause, try and fill in as many as you can, and then check and see if you've got them right. And here they are: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, and n-gon. So anything that we don't have a number of sides that has a name, a very common name. There is a name for 11, but and for 20 and 30 and 40 and etc. But any of these that we don't have listed here, you're going to say, so 13 gone, 14 gone, 15 gone, for our purposes. So they're named by the number of sides. So we have polygons over here on the left, straight lines connecting at their endpoints, not intersecting, not open, not curved, not connected, points that are not connected, and again, more curved examples. We'll talk more about concave and convex on the next page. So we're going to tell whether each of these are a polygon and then name them. So this one, yes, all straight lines connecting at their endpoints, and it has 6 sides, so it's a hexagon. This one, what do you think? Yes, and it has 7 sides, 1, 2, 3, 4, 5, 6, 7, so it's a heptagon. And then this one, no, it's got a curved side here. So that one is not. So what's considered, whoops, moving things all around. What's considered regular is when it has all equal angles and sides. So it's pretty imperfect. All those angles are equal, all those sides are equal. That is a regular polygon. So if it's not regular, it's going to be irregular. So a polygon is considered convex if there's no point that's kind of going into the interior. So if we do have a polygon that kind of goes like this would be considered concave because it's caving into the inside. So a polygon that is not convex is concave. So an example of convex would be kind of our normal stuff. All the points are on the outer side. Nothing is caving in. So concave or non-convex, but we don't really use that term. We use concave or convex. So on letter A, example 1 here, we're going to identify its name, and then if it's convex or concave, and then regular or irregular. So for the first naming, it's 4 sides, so quadrilateral. And then we have convex or concave. It is convex. All the points are on the outer side. Nothing's caving in. And then regular or irregular, well, you can see that these tick marks mean that they're all different side lengths, and you can see all the angles are different too. So it is irregular. And then we have here, we have its number of sides is going to be 9, so it's a nonagon. And then we have concave, because we have this part kind of caving in, and then it's definitely irregular, because all the sides and angles are different. So now we're going to review our area and perimeter. So we've got our 4 common shapes here. The only one that we are missing that is on your worksheet is a trapezoid, and that formula is on there. B1, B2, height. So it's your height times B1, B2 divided by 2. So we'll throw that one in there just so that you have seen it. But I know you've seen it in the past. So there's our formula for our trapezoid. So we have pi with our circle. Pi, remember, is 3.14. If we're rounding it, it's approximately that. But use your pi button if you can on your calculator. So as exact answers, excuse me, make sure that you use your pi button. And if you are rounding, those are going to be approximate answers. And you can use 3.14 but again, I still recommend you always use your pi button. So perimeter for our, I'm going to move this over a little bit here so we've got everything. So perimeter for our rectangle, we have 2 of the same sides. So this side and this side are the same, and then this side and this side are the same. So we have 2 of the 2.3, and we have 2 of the 4.6. So we're going to add all that up, and we're going to get 13.8 centimeters for our perimeter. And you could even write them in if you wanted to and then add them all up. For the area, length times width or base times height, either one, 4.6 times 2.3, and that's going to give you your area of 10.58 centimeters squared. So for our circle, we have circumference is 2 pi r or pi times diameter. In this case, we have our radius, which is from the center to the outside of the circle, is 4. So 2 times 4 times pi. And so you could either put 8 pi, or, which equals 8 pi, or is approximately 25.1 inches. Area, we have here, is pi r squared. So if we put our radius of 4 in here, 4 squared is 16 pi, or that approximately equals, when we use our pi button, 50.3 inches squared. So notice our units when it's perimeter is just inches, and then it's inches squared when we get to area. So units squared when we're talking about area. So then our triangle up here, we want to add up all the sides for perimeter. And so we end up with x plus 4 plus 6 plus 5x. So we can combine like terms here, and that gives us 6x, because we have a 1x here, and then a 4 and a 6 makes 10. So 6x plus 10 units. We then have our area is 1/2 base height or base height divided by 2. So when we take a look at our area, we have our base times our height. Now be careful, because our base is here and our height is here. The hypotenuse is never a base or a height. So base, bottom, and then height, 6. So x plus 4 times 6 divided by 2, what that looks like is taking, and you could distribute the 6 and then divide everything by 2, or divide the 6 by 2 and then distribute. Either one works just fine. So if we distribute and then divide by 2, that gives me 3x plus 12, which is what you would get in the other way. So units squared on that last one. So then on our next page here, we're going to calculate. We know the perimeter for all of them is 88, but we want to find the area of each of these and see which one's the greatest. So for a rectangle, and you can try this on your own and then click play and check, and that works too. So 26 times 18, so that's 468 inches squared for that area. Square, we have length times length, side times side, however you want to think of it. So you could either square it or take 22 times 22, and that's 484 inches squared. Triangle is base times height divided by 2. So in this case, our base and our height, each leg, is 26. So 26, 26. So it's our length, our base, and our height. So 26 times 26 divided by 2, and that's going to give you 338 inches squared. And then a circle, we have our 14 squared times pi, because it's radius squared, pi r squared, and our radius being 14. So 14 squared times pi is approximately 615.8 inches squared. So now we can compare all of them, and we see that the circle has the greatest area. Working backwards here with the problems using a circle first, we know that area is equal to pi r squared. And so we're going to plug in our area is 72.38, and we're going to work backwards. So this is the first step, dividing by pi, and then that's going to give us radius squared equals 23.039. We undo squared by doing the square root, and that's going to give us a radius of approximately 4.8 inches. So on that next one, again, you can try these on your own and then check back in. We have a height of a triangle that we're trying to find, and we know the base is 23. So we know base, we don't know the height, divided by 2 equals 126.5. So we could multiply by 2, and then we could divide by 23. So that gives me 253, divide by 23. So the height is equal to 11 feet. All right, so on this last one, we can count our, I got a lot going on here, I know. We can count our perimeter on this side and this side, but we can't really count these diagonals. So we have to use Pythagorean theorem to find the length of these diagonals. So this triangle right here, we have the base is 1 and we have the height is 4. So 1 squared plus 4 squared is equal to my CB squared. So that's going to give me 1 plus 16, CB squared. So 17 is equal to CB squared. And then we want to do the square root to, again, undo something that's squared. So CB, the square root of 17, 4.12. So 4.1 goes here. So then I have my other two triangles up here, and it's 4, and you can go on the outside or the inside, 4 by 4, and then 3 by 3 to find our diagonals here. So that's going to give me 16 and 16, 32, and then we'll do our square root, and the square root of 32 is going to give us 5.7. And then AE, 9 and 9, so 18, and the square root of 18 is going to give you 4.2. Okay, so now you can add all those up and get your perimeter is 25 units, approximately. So area, I split it up into 1, 2, 3, 4, 5, kind of 3 triangles and 2 rectangles. And here is my kind of breakdown for the area of each. So triangle 1, base times height divided by 2. Triangle 2, 4 times 4, base times height divided by 2. Rectangle number 3, 3 by 5. Rectangle number 4, 3 by 4, and then lastly triangle number 5 here, 1 by 4. So base times height divided by 2. So going through and finding the area of each of those, 9 divided by 2, 4.5. 4 times 4, 16 divided by 2, 8. 3 times 5, 15. And we end up just with a 3 times 4 there of 12. So adding up all of these areas, and that's going to give you 41.5 units squared.